Hello friends, welcome to Shiksharthi. In this video, we'll be taking syllogisms to the next level. So let's start. So this is the first part of the syllogisms in which we had talked about these 4 points. These are the 4 things that we had discussed. Taking this to the next level is now we are changing the subject to the object and the object is being changed to the subject. Meaning thereby, in the first one if I said that all A's are B's, here I am taking it as all B's are A's. Followed by, so this is universally affirmative statement, followed by a particularly affirmative statement like some B's are A's, right? Followed by universally negative wherein I am saying what no B's are A's. And then finally we are discussing particularly negative wherein some B's are not A's. Now taking this, which was the verbal concept, to the mathematical concept level, these are the 4 diagrams that we would be drawing, the basic diagrams. As we had talked about last time, the basic diagram will be basically based on what you are thinking about this, the first interpretation. And then we'll be talking about the alternative diagrams. So you will see that the diagrams are basically the same except for wherever we had A, in terms of A now will be in place of A will be having B and in place of B will be having A. Otherwise the basic diagrams remain the same except for A and B are interchanged, right? So let's see now, does it make any difference? Does it make any difference means if I say all A's are B's and at the same time if I say all B's are A's, are they nothing but the same or are they different is what we are going to infer. But before we do that, what we are going to do here is we will see that an inference, let us say a statement becomes a conclusion. How will I conclude? Now these are statements only. Now these statements, they will be taken as conclusions only when all the diagrams, if the statement satisfies all the possible diagrams. Going further deep into this, if I say all B's are A's, then it should satisfy all the possible diagrams that I would have drawn. Unless it satisfies all the possible diagrams, till then I will not take it as a conclusion. That means a statement becomes a conclusion only and only if it satisfies all the possible diagrams. For example, if these are 4 diagrams, then I will conclude that some B's are A's. And if I am saying some B's are A's, that means it should satisfy all these 4 diagrams. Similarly, if I am drawing these 3 diagrams, that means basically what? Some A's are not B's. No, it doesn't mean this. It means some B's are not A's. And if I am saying some B's are not A's, the statement becomes a conclusion only and only if it satisfies all these 3 diagrams. I hope I am clear on this. But then if I start drawing all the possible diagrams, then it becomes very difficult in terms of it becomes time consuming. And if I am writing any exam, at the same time I need to ensure that the time taken to do a question should also be gauged. I should keep a tab on time. So what am I suggesting here is, let us follow the rule of minimum overlap and maximum overlap. Now when I say minimum overlap, now in this case, what is the minimum overlap that you can have? And what is the maximum overlap that you can have? So you will draw only 2 diagrams. One is for minimum overlap and the other one is for maximum overlap. In this case, this is the diagram for minimum overlap. This is the diagram for maximum overlap. Now if I have to consider it for minimum overlap, I can consider exactly one of these 3 possibilities. So I can choose this, I can choose this, I can choose this. I suggest that you should choose this. So now what is the reasoning behind? Before I go ahead, what is the reasoning behind? We are following the law of extremes. What is the law of extremes? Either a thing happens in totality or a thing does not happen in totality. And the remaining cases will always lie between the things not happening in totality and the things happening in totality. Which is just like saying, taking it to a next level, probability of an event happening, let's say is 0, which is event not happening. and probability of an event happening is equal to 1, which is 100% event is happening. The remaining cases will lie between 0% to 100%. So we may not discuss the cases in between, we can just take the cases, the extreme cases. Extreme cases are minimum overlap to a maximum overlap. I hope this has been fairly understood. Okay, taking this forward, now I know here there is only one case, which is no overlap. So I'll be drawing this only. And in this case, I'll be talking about minimum overlap becomes what? No overlap to a maximum overlap, which could be what? Either I take this or I take this. I would suggest that you take this. Hope that you have understood this. Please remember, in this case, if I am taking these two cases, that means a statement becomes a conclusion only when it obeys these two cases. In this case, this statement becomes a conclusion if it satisfies this. In this case, this statement becomes a conclusion only if it satisfies these two cases. If it satisfies these two cases, that means it will satisfy all the cases in between, following the law of extremes. And same here. So now, time for the application of what we would have discussed in the first part of syllogisms and the second part which is going on. Time to draw a synergy between the two. So now when I am drawing a synergy between the two, I would request you to focus your attention here. So now when I have drawn these two diagrams, you would see that are these two diagrams equal? Here, maximum overlap, they are equal. But for minimum overlap, they are not equal. So is it equal to, if I say that all A's are B's, it's just like saying all B's are A's. Are both the statements the same? No, because they do not have the same kind of possibilities. If I talk about the maximum case, the maximum overlap case is the same, but the minimum overlap cases in both the cases is not the same. So which is why we have concluded here, case 1 is not equal to case 5. Right? Let us come down to case 2. Now if I see this diagram, minimum overlap diagram, are they same? Yes, except for B and A, they are the same. The remaining all the cases, if I talk about this diagram, where is this diagram located here? Here. This diagram, yes. This diagram, yes. So can I say that case 2 is equal to case 6? Of course. So if I say some A's are B's, can I conclude some B's are A's? Of course I can. And we have proved it mathematically and verbally, both. Right? Okay. Now, if I say, now the third conclusion is, we are saying 3 is equal to 7. What is 3? No A is B. It's just like saying no B's are A's. The diagrams are exactly the same. Right? Last case, if we are saying some A's are not B's, let us compare their diagrams. So these two diagrams are the same. These two aren't. Even this is not the same as this. So can I say, if I say some B's are not A's, can I say some A's are not B's? No, I can't, because they are not the same statements. So henceforth we will say case 4 is not equal to case 8. I hope this has been understood. If I were to take some examples, I can say, if I say all congruent are similar, the example that I had taken in my earlier video. All congruent triangles are similar triangles. But at the same time, can I say all similar are congruent? No, I can't. Just to prove this. Right? At the same time, taking one more example, if I say some A's are B's, at the same time I can conclude some B's are A's? Of course, we just proved it. So if I say some prime numbers are odd numbers, at the same time, can I say some odd numbers are prime? Of course I can. Okay, taking it forward now. So now, which is the next level? Next level is again the application level, wherein if I say all A's are B's, and in the first part of the syllogisms, we talked about all A's are B's, and we also talked about some is a subset of all. So if I am saying all A's are B's, at the same time it infers, it means, or it concludes that some A's are B's, right? And few minutes back only we talked about 2 is equal to 6. So if 1 concludes 2, that means 2 concludes 6. I hope this is understood. Similarly, if I am saying, now which is the fifth part, if I am saying all B's are A's, analogously, at the same time I can say some B's are A's, which is 6. Now 6 is equal to 2. So if 6 concludes, that means at the same time I will have a conclusion as case 2 as well. Right? Similarly, 3. Now the third part of no A's or B's. Now when I say no A's or B's, it is just like saying no B's or A's. At the same time I can say what? Some A's are not B's. And I can say what? Some B's are not A's. So I am getting a Z from here. I'll repeat. No A's or B's is just like saying no B's or A's. Right? And we know that some not is a subset of no. So we started off with 3. If 3 and 7 are conclusions, I mean from 3 I can conclude 7, and now both of them can be taken as conclusions. So if I am saying that some, if I am saying no A's are B's, at the same time I can say some A's are not B's, which is just like saying conclusion 4. And if I am saying no B's are A's, at the same time I can say what? Some B's are not A's. I hope this has been fairly understood. Last but not the least is the same case. So if I am saying no B is an A, at the same time I can say no A's are B's. Now when I have said no B's are A's, I can say some B's are not A's. At the same time I can say some A's are not B's. Right? I would suggest practice this as much as possible. Until the time your concepts are clear, do not start off with the questions. Because if you do it halfway, this topic becomes further difficult. Right? If you think that you learnt something today which gave you a fresh perspective towards syllogisms, please do not forget to like, share and subscribe to our channel. If you have already done the same, please turn on the bell icon so that you can start receiving updates. Yeah. Thank you so much. Until next time we meet. Goodbye.